So there's an additional point to make about p integrals, which we'll make through the following example. Ask, does the integral from 10,000 to infinity of 1 over x to the point 0.9, and just to be clear, that's not x times 9 or x times 0.9, that's x raised to the 0.9 power. Does this converge or diverge? The way you want to think about this is we know already that if I integrate, if this is y equals 1 over x to the point 0.9, we already know that if I integrate it from 1 out to infinity, that this diverges. In other words, the area is infinite because this is an integral. This is a p integral with p equal to 0.9, which is less than or equal to 1. So we can easily say that diverges. The thing to understand here is that if, let's suppose that I start this, I'm just going to indicate sort of a break and say that this goes, let's say that we start at 10,000. What we know is that if the whole area, if the whole green area adds up to infinity, if I remove the interval from 1 to 10,000, in other words, this is a length of 9,999, whatever it is, this area here, which I'll shade in yellow, this yellow area is a finite number. So all I'm really subtracting from what I already know that the whole area from 1 to infinity is going to be infinite. I'm going to subtract some finite number. This is just an ordinary finite interval, the finite area under a curve on a finite interval. It doesn't affect whether the integral adds up to infinity or a finite number. So the point is that what we really care about when we're determining whether a p integral converges or diverges is this, what we're going to call the infinite tail. So the point is that the integral from a to infinity of dx over x to the p, that's a to infinity, it behaves like the integral from 1 to infinity of dx over x to the p, because for any finite number, for any a greater than or equal to 1, because all we're doing is just removing some finite amount of area from the total amount of area. It doesn't change whether it comes out to an infinite number or a finite number.